Hello everyone. Today I am going to take a class on Lorentz transformation. Lorentz transformation is a set of equations in relativity physics that relate the space and time coordinates of two systems moving at a constant velocity to each other. Consider two reference frames S and S prime moving with uniform relative motions. Let two observers O and O prime observe any event P from systems S and S dash respectively. For the observer at O, the coordinates of the event at a particular instant B means the coordinates at the position P will be x, y, z, t. The same event is described by the coordinates x prime, y prime, z prime, t prime for the observer O prime on the system S prime. Initially, when S and S dash coincides, t is equal to 0 and t prime is equal to 0. After a time t is equal to t, S dash moves about a distance vt from S. The total distance from the observer O to the point P is x. So from the figure we can calculate x prime is equal to x minus vt into a constant k. K is a function of velocity. Then equation 1 gives relation between x and x prime. Since S dash moving along S dash is moving along x direction, the motion doesn't affect y and z direction. So from that we can write y is equal to y dash and z is equal to z dash. Now the initial condition get reversed. That means the former gets into a motion and the latter will be at rest. Initially S is at rest and S prime is moving with a constant velocity. Now the condition is reversed and S prime is at rest while S is moving with a constant velocity v. At initial condition, S and S dash gets coincides. So t is equal to 0 and t prime will also be is equal to 0. After a time t prime, the first frame of reference S moves backward with velocity v. That's why I denote it as minus v on the figure of first frame of reference. After a time t prime, S moves about a distance vt prime from S prime. That's what denoted in the second figure. From the figure we can write x, that's the total distance, x is equal to k into x prime plus vt prime. Here also we are using the constant k because the same constant k is used since according to the first postulate nothing distinguishes s and s prime from one another. So we can use k in this equation also. Now substitute equation 1 in equation 2. So we get x is equal to k into so we can write x is equal to k into inside bracket k into x minus vt plus vt prime. Open the bracket, then we get k into kx minus kvt plus vt prime. So we can write kx is equal to multiply k into inside the box. We will get x is equal to k square x minus k square vt plus kv t prime. Now move the first and second term of the right hand side to the left hand side of the equation. We will get x minus k square x plus k square vt is equal to kv t prime. From that take x common in the left hand side. We will get x into 1 minus k square plus k square vt is equal to kv t prime. Now, um, from the right hand side, move kv to the left hand side. So we get x into 1 minus k square by kv plus kt is equal to t prime. So we got the equation of t prime. T prime is equal to x into 1 minus k square by kv plus kt. So we get a bundle of four equations. First one is x prime is equal to x minus vt into k, y prime is equal to y, z prime is equal to z, and t prime is equal to x into 1 minus k square by kv plus kt. So the next step is to get an explicit form of constant k. Now we are going to find the value of k. So let us assume that event is a pulse of light emitted from O at the time t is equal to 0. So observer O finds distance travelled by light as x is equal to ct, and observer O prime finds distance travelled by light as x prime is equal to ct prime. So put this as equation E and F respectively, and then substitute A and B in equation F. That means for x prime is equal to x minus vt into k, and t prime is equal to x into 1 minus k square by kv plus kt. Substitute these two equations in equation F, that is x prime is equal to ct prime. Instead of x prime, substitute the equation A in it, and instead of t prime we can replace it by equation D. So we will get k into x minus vt is equal to c into x into 1 minus k square plus k square vt by kv. By rearranging, we can write k square vx minus k square v square t is equal to xc 1 minus k square plus c k square v. The second step is got by moving the denominator of the right hand side equation to the left hand side. Now take x and t common in right and left hand side respectively. Then we will get equation as g. Divide equation g by equation e. Equation e is x is equal to ct. Now divide equation g by x is equal to ct. So we will get k square v minus c into 1 minus k square is equal to 1 by c k square v plus k square vc. K square vc minus c square into 1 minus k square is equal to k square v square plus k square vc. K square vc on both sides can be cancelled. So from that we will get k is equal to 1 by root of 1 minus v square by c square. This is how we got the value of k. Now equation A, which means x prime is equal to x minus vt into k, will becomes like x minus vt by root of 1 minus v square minus c square. That means we are replacing the value of k as 1 by root of 1 minus v square by c square. Then similarly t prime will also get changed like this. The initial equation for t prime is equal to x into 1 minus k square by kv plus kt. Now replace the value of k as 1 by root of 1 minus v square by c square. Like this, x into 1 minus k square by kv plus kt will become x minus, we are opening the bracket, x minus x into k square plus k square vt by kv, taking kv as LCM. Then x minus x into putting the value of k square as 1 by root of 1 minus v square by c square, plus again putting the value of k square into vt by putting the value of k, that is 1 by 1 minus v square by c square into v. So we will get x into 1 minus v square by c square minus x plus vt divided by 1 minus v square by c square into root of 1 minus v square by c square by v. X and x got cancelled, and we will get vt minus x v square by c square by root of 1 minus v square by c square, that is equal to t minus xv by c square by root of 1 minus v square by c square. Here we are taking v as common and get cancelled with the denominator. Then we will get another equation for t prime, which is equal to t minus vx by c square into 1 minus root of 1 minus v square by c square. Put this equation as I. Now z prime and y prime didn't get changed, so it remains as initial equation. Now we are going to substitute the value of v by c as beta and 1 by root of 1 minus v square by c square as gamma. Then equation h become equation h is the equation of x prime. Then x prime becomes x minus vt by root of 1 minus v square by c square becomes gamma into x minus vt. And or we can write x prime is equal to gamma into x by x minus beta into ct. Then equation I becomes ct prime is equal to ct minus cvx by c square into 1 minus root of 1 minus v square by c square. Equation I is the equation of t prime. Here we are in the equation of t prime, we are multiplying the term c in both left hand and right hand side of the equation. That's why we are getting ct prime is equal to ct minus cvx by c square into 1 minus root of 1 minus v square by c square. By rearranging, we will get ct prime is equal to gamma into ct minus beta x. Then y prime and z prime didn't get changed. Here we are only interested in transformation for which t prime tends to t and x prime turns to t, x prime turns to x, as beta turns to 0. As matrix, this transformation appears as while writing in the form of um, the first in the first matrix, the A1, A2, A3, and A4 are the coordinates which we have found, that is ct prime, x prime, y prime, and z prime. Then is equal to another matrix. This matrix is derived from the coefficient of ct, x, y, and z. So in the second matrix, uh, the first column represents the coefficient of ct. The second column represent the coordinates of x. The third column represent the coordinates of y, and the fourth column represent the coordinates of z. So first consider the equation ct prime is equal to gamma into ct minus beta x. Here A11 is the coefficient of ct. From equation m, we can write the coefficient of ct as gamma. So A11 become gamma. Then A12 is the coefficient of x. From equation m, we can write the coefficient of x as minus gamma beta. Similarly, here there is no coordinate for y and z. So coefficient of y and z at 0. So A13 and A14 become 0. Similarly, the rest 3 rows can be written. So well, that's all about my topic, Lorentz transformation. Thank you for your attention.